Hi, I'm an old guy and I do maths. Our problem today is, I guess, substantially a geometry problem, but all sorts of other elements come into it. A right-angled triangle has obviously three sides. They measure x, x plus 3, and x plus 4. So we don't have numbers for them. We have expressions, pronumerals. What are its exact measurements? Well, let's start with figuring out what this looks like. So let's draw it in here. Let's just get this sorted out. So there's our right-angled triangle. Now, the sides, x, x plus 3, x plus 4. Reason suggests that this is the shortest side. Why? Because this is something greater and this is something greater again. So it's important that we get these sides in the right place. So the next largest side is x plus 3. X plus 4 is the longest side. Again, it stands to reason. And the longest side is the hypotenuse. Okay, so where do we move from here? Well, we have a right-angled triangle and we've been asked about its measurements. Hint, Pythagoras. Okay, so what do? Well, we do what this says. A squared plus b squared equals c squared. X squared plus x plus 3, all squared, equals x plus 4, all squared. Now we have a little bit of work to do here, but let's not shy away from that. We'll expand both of these perfect squares. They are perfect squares, and if you don't understand what is going on, please have a look in the playlist at how you expand perfect squares. But this perfect square expands to this. So it's x squared, 3 squared on the end, and 3 times 2 times x in the middle. And something similar for this, x squared plus 8x plus 16. Now, we need to sort out and simplify this. So 2x squared plus 6x plus 9, which simplifies this side, equals x squared plus 8x plus 16. Now, what we want is we want everything on this side of the equation, and we want a nice round 0 here. So, tidying this up, 2x squared minus x squared gives me x squared, 6x minus 8x minus 2x, 9 minus 16 gives me negative 7. We need to solve that equation for x. Now, how do we do that? Well, we have some choices. We can complete the square. We can use the quadratic formula. I'm going to use the quadratic formula. I think it's going to be easier in this case. So, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a is 1, b is negative 2, and c is negative 7. So x is equal to 2 plus or minus, so negative b is positive 2, plus or minus the square root of b squared. B squared is 4, minus 4 times 1 times negative 7, all over 2. Which gives us 2 plus or minus the square root of 4 ones are 4, that's negative 4 times negative 7 is positive 28. 28 and 4 is 32, all over 2. So x is equal to this expression here. Now we can simplify this. Let's deal with the first bit of this. Actually, let's break this up. It's 2 over 2 plus or minus root 32 over 2. So that gives us 1. So x is equal to 1. Now, 32 over 2. This is, where have I got some room? I'll just come over here and deal with this. So root 32 over 2 is a half root 32. So our quest is to find out what this equals. And this is 16 times 2. And we're multiplying that by a half. The square root of 16 is 4. So it's a half times 4 times root 2, which is 2 root 2. So 32 on 2, root 32 on 2 gives us plus or minus 2 root 2. Okay, well, we have a couple of potential values for x. Now, the question is, which one of these do we pick? Can they both be right? Well, they can't both be right for a very good reason. The square root of 2 is approximately 1.41 something. So 2 times 1.4, let's say, if we subtract that from 1, we get a negative value. So if we take the negative value of this, we're going to get a negative measurement for which there is really no such thing. We're talking about the size of something, we're talking about its magnitude, so it must be a positive value. So x is equal to 1 plus 2 root 2. So what are the measurements of this thing? Well, if I draw this roughly, this is 1 plus 2 root 2. This side is 3 plus x, so that's 3 plus 1, 4 plus 2 root 2. And the hypotenuse is x plus 4, which is 4 plus 1, which is 5, plus 2 root 2. And just for the sake of completeness, the perimeter of this would be 1 and 4 is 5, and 5 is 10, 10 root 2. And the area of this would be 1 plus 2 root 2 times 4 plus 2 root 2 divided by 2. That's everything. That, anyway, is how you find what the value of the sides of this triangle are, the values, are in exact terms. Thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.